voltage will be positive. Then the quadrant of operation, so the first quadrant means forward motoring. Yeah. So now if you do we have now as seen now it's in this case RLE load, no, you will have this continuous conduction mode and then this continuous conduction mode. So in this continuous conduction mode, so continuous conduction mode, when will the device will have continuous conduction mode? When the inductance of the device is very high, then it will be continuous conduction. So usually in DC motor we have so for the analysis part we are right now we will consider both, but however in practical consideration the DC motor will have this continuous conduction mode only, mode of operation. Okay, so because of its very high inductance, presence of very high inductance. Otherwise this is the discontinuous conduction mode. Just for understanding purpose we'll consider here. However in practical this is the case, the continuous conduction mode only, because of its high inductance, presence of high inductance in the winding. So in this case the devices involved in operation are, so now if you see this, so here full half semiconductor, so you can see in this case what you are having. So 0 to alpha, so 0 to alpha means so this region, which one will conduct? Forward or freewheeling diode will conduct. Okay, now between this region which diode? Alpha to pi. So between these two region which will be conduct. So in this case T1 and D1 will conduct. Okay, so T1 and D1, so between this till here. Then when it is, this one is now at alpha or at this omega t is equal to or theta is equal to pi, voltage is 0. However the current will not be 0. Why? Because of this presence of that inductance. So then stored current will flow through this star. So this, in this area the current will not be 0. So if you see, so there will be a current flow in this case. Okay, when voltage is 0, so IA is not 0 here. So I will not be 0 in this case. Okay, so continuous nothing, but it will be, you are showing is 0 where it will be there, becoming 0 at same time, continuous. However, you will have this no IA is this IA will have freewheeling diode. Okay, load current will flow. So this is why. So now if you add these two, so current will be flowing still when the voltage is 0. And then voltage has started, in this case it will be 0 now. That is where it will be. Okay, so this is what. Then pi to 2 pi plus alpha, again from pi from here to 2 pi plus alpha here, forward or freewheeling diode will flow. Then similarly next cycle. So this is what actually you have. So working the same mirror that as that of RLE load, na same mirror, that is continuous conduction mode. Then analysis part, you can have is VA is equal to VM by, this is the equation here. Then for separately excited motor, we have the voltage equation is this. So when you compute this, you will get this. Okay, so you can use, so in assignment I have given you question, so you can use these formulas there. Okay, so the formulas 4.1, 4.2, 4.3, 4.4, 4.5, all these things. So you can use these formulas to solve that numerical. Okay. Then discontinuous conduction mode, nadi devices involved. So in this case, what will happen when the inductance is less? So it will be disconductance. So when inductance is less. Okay, so when inductance is less, then you will have this discontinuous conduction mode. So here now you see this disconduction means conducting when voltage is 0, the current is not 0 here. So this one continuously it was showing, but we are showing separately. So source current will become 0 when the source voltage and all this thing. But here the current through the load current will not be 0. Okay, so this is what actually it is. So disconduction mode. When there is the thyristors and diodes will not conduct, but freewheeling diode will conduct during the discontinuous conduction mode. Okay, so these are the case. So beta to alpha plus beta. So this beta, this one, this angle, extinction angle, we call it as extinction. No, this beta is called as extinction angle. So that is no conduction is there. So Similarly, so you will have is beta in this case. So this is the only case you will have. So you can Vm 1 plus 4.5 key. So this is what. Then now next is now you replace that D1, D2 by T3, T4. Then you will get is full converter. Okay, so full converter. So here this one. So now you will have is T2, T4. So you can replace that one. Okay. Also you can have that same thing. The working will be more or less same. Then in this case, what you will have is it is now this one is a two quadrant operation. So if you see, so it will operate in first and fourth quadrant. So this, okay, so this is realized to operate or forward motoring and then reverse braking, regenerative braking. So first and fourth parameters as it is same you will have. So now if you can see quadrant operation, you can see this is the case. So first quadrant operation or forward motoring, you have nature of load voltage and current is both are positive, right? Voltage positive, current also positive. Then first quadrant operation, if you can see, this is the, so your continuous conduction mode, that is your continuous conduction mode, you can see. So you can have that part. Waveform, device involved in operation, that is the figure. So this is the full wave if you are watching. This you get. Okay, so you can see full converter. So you are continuously you are getting converter. Then similarly, VO, that is from the electrical machine perspective. This is from power electronics point of view, and this is from the electrical machine point of view. So back and the back EMF and the armature resistance, armature current relation. Then fourth quadrant operation or reverse regenerative braking mode. So in this case, load current and voltage nature of load voltage and current are that voltage will be negative whereas current is positive. So fourth quadrant operation in this case you are having is